All right, we're back. We are on page 61, it looks like, of math analysis, and we're talking about inverses, and we just spent a lot of time coming up with the graphs. I don't even use the graphs, but it's important that you know them, that you know where they come from, their key features. It's all about like getting your brain to think in a different way. And the different way that you need to think in this case is you need to think in inverses, which is, I don't think that's really a thing, but you need to be able to think in inverses. So think backwards, right? And this is not normal, right? You haven't been dealing all year with like, on the unit circle, where is y equal to 1/2? On the unit circle, where is x equal to negative √3/2? That's the questions that we're answering now, but they're very specific. So the specific thing that we're dealing with looks like this. So if you have arcsine of x is equal to theta, which is what it is, right? Arcsine is a weird way of writing an angle. Get that into your head. Inverse, so if we do, I like to call them the arc trig things. You do arc trig of a ratio or inverse trig of a ratio, and it gives you an angle, right? So if I say the inverse sine of 3/78, I don't know, 3/7, well, that reduces, but inverse sine of 4/78, right? That's an angle. Like, I don't know what angle that is. I know it's in the first quadrant because it's the inverse sine of a positive. I don't know what angle it is, but I know it's an angle. It's a weird angle. So if you see arcsine of theta, what that really means deep down inside is that theta is the angle between -pi/2 and pi/2, inclusive, whose sine is x, right? So you have to think backwards. This is saying to you, where on the unit circle is the y coordinate something. That's what arcsine means. But it's really specific. It's just where on the unit circle between quadrants 4 and 1, where 4 is negative, is the sine value of a certain thing. So that's what we're dealing with. And you get one for each. Arc cosine is going to be between 0 and pi, inclusive. Arc tangent, get going. Arc tangent is going to be between -pi/2 and pi/2, but exclusive. You're not allowed to count those, nor would you ever. I mean, it's never going to even come up, but you know, you have to get, those are the sorts of things, you got to get them right, even though like they can't happen. So let's see if we can like think our way through this. So this, again, you should memorize them, but you also want to be able to kind of explain them and think your way through it. So here, what I usually do is I immediately say equals theta or equals something. So this is equivalent to saying that the sine of theta is 1/2, where theta is an element of -pi/2 to pi/2. That's what it's saying, like find theta. Those are equivalent. Now, the other thing is that we're talking about this, right? Solid dots. But no matter how you do it, like where is sine of theta equal? So where is sine of theta equal to 1/2? Well, 1/2 is like here, and that's like pretty far out. That angle is pi/6. The inverse sine of 1/2 is pi/6. So these are equivalent things. If you're talking about cosine inverse of 1/2, that's equivalent to saying that the cosine of theta is equal to 1/2, but theta is an element of 0 to pi. Well, what does 0 to pi look like? 0 to pi looks like the top half of the unit circle. I'm realizing if I draw this a little bigger, it might be helpful. And then depending on how your like mental geometry is, you can actually kind of geometrically work it out. That must be pi/3. Like that feels like where it should be. And it is pi/3. And we have that memorized, but also we can do it kind of geometrically, thinking of the unit circle and like distances, or you can think like cosine equals 1/2. Cosine equals 1/2, that means you're either in quadrant 1 or 4, but you can't be in quadrant 4 because this is arc cosine. So it's a lot going on, like a ton. Equals theta. So what is this equivalent to? The tan of theta is -3/3, and theta is an element of, so we're not allowed to include them this time, -pi/2 to pi/2. This is where the quadrants matter a lot. So this is equivalent to this picture. I don't find this picture as useful other than knowing the asymptotes, right? Because of those open circles, you're going to have an asymptote y equals pi over 2, y equals negative pi over 2 for the graph of arctan. I find that very useful. But what I really think is root 3 over 3 is a pi over 6 angle. Since it's negative, I've got to come from here, so it's going to be a negative pi over 6. That's how I like work my way through it. And here, call it theta, write your equivalent thing. So cosine of theta equals negative root 2 over 2. There's an infinite number of angles for which cosine of theta is negative root 2 over 2, right? So there's 3 pi over 4, 5 pi over 4, and then anything coterminal to those. Their cosines are all negative root 2 over 2. But since you started out with inverse cosine, this is a more specific thing. We actually know that the angle has to be between 0 and pi. There's only one angle where that's true. And that means that we're going to be talking about 3 pi over 4. So like here. So this has to be 3 pi over 4. Maybe. Yeah. I don't know. I'm halfway through that. I just like totally forgot what I was doing. And then here, this equals theta. This is where your picture is going to be super helpful. So we're saying that sine of theta is negative 1. But we're also saying theta must be an element of negative pi over 2 to pi over 2. So if that's the case, what does that look like on the unit circle? This. Where's negative 1? Well, negative 1 is right there. So that's got to be negative pi over 2. You just kind of like get the answer from that one. I think that's incredibly useful. What are the rest of these? You know what? I'm going to do them, I think. Maybe. So I did point this out before. The range of the inverse functions. I'm going to highlight this in like an obnoxious color. The range of the inverse functions is super important, right? Because they're functions, which means there's only one value satisfying it. The inverse sine of something is one number and only one number. There's a difference between solving this equation where you're just saying like where on the unit circle, you know, sine of x equals negative 1. Think about graphing sine. If you graph sine, that happens in an infinite number of places. It's every time you hit a minimum, you're at sine of x is negative 1. So that has an infinite number of answers. This, on the other hand, the inverse sine of negative 1 has exactly one answer because inverse sine is a function. There's only one answer to that. The inverse sine of negative 1 is negative pi over 2 and nothing else. So there's a huge difference between how the problem is presented to you. If it's presented to you as sine of x equals negative 1, in my mind, I'm like, where does the graph of sine hit negative 1? If it's presented as the inverse sine of negative 1, I think, where on that little part of the unit circle is the y-coordinate negative 1? You have to know the difference between those. Because if you don't, you're going to get a lot of things wrong. And we don't want that. So here's another way to think about this. So inverse sine, unit circle picture, we're here. Inverse sine of 1/2. So what kind of angle has a sine of 1/2? Pi over 6. If we're in quadrant 4, or rather, well, I blew that. If it's the inverse sine of a negative, since sine is positive in quadrant 1, it must be coming from here. So what angle would that be? It'd be negative pi over 6. This is another way of doing it. This, I think, it's hard for me to remember at this point. I think this is how I did all these problems when I was in high school. I think I would think where on the unit circle, and then what's the reference angle, and then boom. I think that's what I did. I don't actually remember anymore. And now what do? Now I just have them memorized, so it doesn't really make a difference. But you got to know all this stuff so that you can present it to others. So where's tangent 1 or negative 1? That's a pi over 4 type angle. If it's tangent and it's negative, it must be quadrant 4. So this must be negative pi over 4. So you can just kind of go through this checklist and you will get your answers. So here, kind of lost it there. Reference, so what types of angles have cosines that are 1/2? Those are the pi over 3s. But I got to be in this quadrant because cosine's negative. So what's the pi over 3 in quadrant 2? It's 2 pi over 3. Tangent. Tangents are probably the hardest because you just think about them the least, especially the non-quadrantals, I guess. But even half of the quadrantals, tangent doesn't exist. The non-pi over 4s, let's say. Pi over 4s are super easy. They're all 1 or -1. So here it's tangent. It's a root 3, which is a pi over 3 type of angle because the tangent of pi over 3 is root 3. Positive, which means we're in quadrant 1, which means the answer is actually pi over 3. And there you go. That's 2 different ways of tackling these. Think about both of them really, like, and try to use both of them as you go through the process. Because when we get to non-standard angles, you're probably going to want to fall back on both of these. And so you need to have them available. So anyway, I'm going to stop this here. Hope you found this helpful. See you in the next one. Yeah, that's it.